This is lesson 8.4, Properties of Logarithms. Now that you know what a logarithm is, how it's another way to write an exponential function, we want to talk about how do you combine logarithms, or how do you simplify them when you see more than one. So we have some properties that we talk about, and the idea is that if you have two logs and they are connected by by addition or subtraction, they can be written as a single log. So we go from having two logs to a single log. Notice that they all have the same base. When they are connected by addition, we say that you take these two inside numbers and you multiply them together. When they are connected by subtraction, we say that you take the two inside numbers and you connect them by division. We call this the product and the quotient properties. The other one that we have is that if you have a coefficient in front of your log, so something times the log of base b of m, it can be written as an exponent on the m. It can move back and forth. So first thing we're going to do is practice identifying these properties. So in this first one here, we have addition, and there's no coefficients, so we have the multiplication or the product property, where 2 times 6 is 12, and it's a single log, so product property. In the next one, we have division here, right here, 4 divided by 2, and it's the subtraction. We also have threes, or coefficients of threes, which means we have a power. Notice the 3 went on to the 4 and 3 went on to the 2. It's now the power. So we have here the quotient and power properties. And then in our third example, we have a coefficient again. This time it's only in front of the log with the x, so you'll notice that that power only shows up on the x. It doesn't share with the y. And we have addition. So again, we're going to have multiplication of the two numbers on the inside. So we have product and power properties. So now we want to practice using these. We're going to practice combining and expanding. To combine logs means, like you see in this first set here, example 2, you're going to take two logs as long as they have the same base, and we're going to write a single log with that same base, combining the inside numbers. Expansion, we'll take a look at, that's when you have one log and you write it out into many logs. So this one here will be log base 3, and because this is subtraction, we're going to have 64 divided by 16, which we can simplify further to be log base 3 of 4. Now, it's important that when you have powers out in front, like here you have a 3, it's important that you do that first. So we're going to move that onto the 2 before you do anything else. So log base 6 of 2 to the third, which is the same thing as log base 6 of 8. So that needs to be the very first thing you do before you try to combine any of the other logs. So notice up here, when combining, do the power property first. Once that's done, we can deal with the rest of the problem here. So we have log base 6 of 8 plus log base 6 of 4 minus log base log base 6 of 16. So when we combine these, think about doing your first two first. We have these two guys will become log base 6 of 8 times 4, so that is 32. And then we have minus log base 6 of 16. So when we put these two together, we have log base 6 of 2, because 32 divided by 16 is 2. So this is our answer there. All right, yet again, we have another power, so make sure that you do that first. Put that onto the x. So we have log base 5 of x to the 6th plus log base 5 of y, which equals log base 5. It's a plus, so it'll be multiplication, x to the 6th, y. Now when we look at expanding and doing our logs, since this is the reverse of combining, we're going to make sure we do the power property last. We'll see what that looks like here in just a second. So expansion, like I said, here's the single log. We want to think about everything that's inside of the log and write a separate log for each piece. So since these are connected by multiplication, this will be log base 2 of 7 and log base 2 of b. And this part here will put a plus between them. Now there's nothing else to separate from the 7 and nothing else to separate from the b, so we are set to go. On this next log, again you have log of 4 and log p3. Because they're connected by multiplication, it will again be a plus. But notice we now have the power here. That has to be taken care of. That is going to need to come down as a coefficient in front. So this can be written as log 4 plus 3 log of p. And again, remember that if there is no base written in here, like there's no base written down there, you assume that the base is 10. It's a common log. You don't have to write it in. So you can just leave it as log 4 plus 3 log p. All right, next one. This one we're going to have log base 2 of a to the third and log base 2 of b to the fourth. Since there's division in here, it will be a minus sign, and then we'll move both of our powers down to be coefficients in the front of the logs. So we have 3 log base 2 of a minus 4 log base 2 of b. Nothing else with the a, nothing else with the b, so we're done. All right, so that's the basic idea of combining and expanding logs. Let's take a look at a couple more examples. So 8.4b, here's a continuation of your properties. The big thing that we're going to see in some of these examples is when you see the square root in here. Now remember that when you have a square root, that can be written as a power of 1/2. That's one of your exponent rules. So that means that we could write this as 1/2 times log of x. That's using our power property right here. So if we're going this way, you're expanding. You're taking something from the inside and moving it all the way to the outside. If you're moving this way and taking something as a power, putting it on the inside, you're combining. All right, so if we want to practice this a little bit more here, write each expression as a single logarithm. This one would be log base 3, 16 divided by 4, which is log base 3 of 4. Take care of the power. So you have log base 5 of x squared plus log base 5 of y equals log base 5 x squared times y. That's what we're just working on our previous page. Now, if we're going to expand, we need to focus in on the square root as being a power. So you need to think about this as being log base 2, 7 to the 1/2 power times b. And once you think about that as a power, then we have log base 2 of 7 to the 1/2 plus log base 2 of b. And this comes out in front. So it's 1/2 log base 2 of 7 plus log base 2 of b. Now when you have a square root over everything, you need to think about everything on the inside of this log as having a 1/2 power. So this is really saying the 3 was under a square root, and the x was under the square root, and the y was under a square root. So when we rewrite this, we get log base 2 of 3 to the 1/2 plus log base 2 x to the 1/2 minus, because it's on the bottom, it's divided, log base 2 y to the 1/2. And then those 1/2 powers will all come out in front, so they will become coefficients for us, where we have 1/2 log base 2 of 3 plus 1/2 log base 2 of x minus 1/2 log base 2 of y. All right. Now, sometimes when you're looking at logs, it's as simple as it can get, right? There's log base 2 of 3, and there's nothing else on the inside that we can do there. The x is as simple as we can get. The y is as simple as we can get. But sometimes when we're dealing with a log and we combine it into a single log, we can actually evaluate it. Remember that evaluating means to find the value of, to find its worth. So if I say evaluate log base 2 of 8, I'm really asking, what is this piece worth? Well, it's worth 3. It's saying 2 to the 3rd power is 8. So that's what we're going to do with these. Not only are we going to combine them into a single log, but we're also going to find their worth. Remember that you should do the power property first when combining. So to combine these, we'll have log base 2, 16 divided by 4, which is log base 2 of 4. And now I want to know, what is it worth? Well, this is 2 to some power is 4. 2 to the 2nd power is 4. So this phrase is worth 2. On our next one here, when we do the power property, we're going to have log base 2 of 4 to the 3rd minus log base 2 of 8. 4 to the 3rd would be 64 minus log base 2 of 8. So we have log base 2, 64 divided by 8 is 8. And then asking, what is this worth? So 2 to what power is 8? 2 to the 3rd. So this phrase is worth 3. On our next one, put our power properties on here as well. So the 3 goes on the 1. We'll have log of 1 to the 3rd. And again, 1 to the 3rd will just be 1. Plus log 100. When we combine this, it's multiplication. So 1 times 100 is still just 100. And if there is no base written, that's base 10. So 10 to what power is 100? 10 to the 2nd. So this is worth 2. All right, and last example here. Here's a power. We need to move that onto the 2. So we have log base 2 of 2 squared, which is 4, minus log base 2, 16. And when we have 2 squared, so 4 minus log 2, 16, we have log 2, 4 divided by 16, which is 1 over 4. So we're asking 2 to what power is 1/4? So think about your 2's for a second here. We know that 2 to the 0th is 1. We know that 2 to the 1st is 2. 2 to the 2nd is 4. And these numbers are getting larger. We don't want larger numbers. We want smaller numbers. So let's go the other way. 2 to the negative 1 is 1 over 2 to the 1st. 2 to the negative 2 is 1 over 2 to the 2nd. 2 to the 2nd would be 1/4 here. So this is worth negative 2. All right. So now you've seen a bunch of different examples for combining and expanding logs using your product, quotient, and power properties.